Hi everybody, in this video I want to run through some Excel functions for the section on hypothesis testing for means where sigma is unknown. So remember, sigma is your population standard deviation. So in this case we're trying to do a hypothesis test for a mean, but basically you don't have any population data, you only have sample data. So in that case we're going to use a t-distribution instead. And again, we're going to assume all the other requirement checks are met here and that we're able to actually proceed. Now, for hypothesis testing, there are two main strategies that we can use here. So there's one method that's called the critical value method, or sometimes people will just say like rejection region method. And there's another method called the p-value method. Now, in class, we actually did use a table to find the critical t-values when doing the critical value method. And it actually is very easy to use. So if you're comfortable and you like the table, then you don't have to do the Excel. But if you prefer Excel, I'm going to show you the function that you can use here if you would like. So we're going to assume that we have a left tail test. Again, just kind of to do an example. We're going to assume our alpha is 0.05 and our sample size is 14. But again, we're going to assume that all other requirements have been met here. So we're able to actually proceed. Now, if we start with the left tail test, and again, we're going to do this first method here. So we're doing the critical value or rejection region method. What ends up happening is the alpha is the shaded area on the left side of the graph. The formula that we're going to use here is going to be t dot inverse. So it's this first one here for t inverse. We're going to click that. And then you're going to go ahead and you're going to put in always the area to the left. So here we can use that 0.05. And the degrees of freedom in this case, remember, are going to be n minus 1. So 14 minus 1 is 13. And if I do that, I do get my critical t value. So one more time, I hit t dot inverse. My alpha here is 0.05, and my degrees of freedom is going to be 13. Now, when you have a left tail test, your critical t value is actually negative because it's on the left side of the graph. How do we adjust that for a right tail test? Well, there's different ways you can do it, but one of the easiest ways is to just do exactly what we just did, but make it positive. So we'll say 771 here, rounding to 3 decimal places. Again, you could also think about the shaded area here. That works as well. You would use the opposite of this. So you would use 95% because, again, you're doing the other side, so your shading is all the way on the left. That works. But because we have symmetry here, if you're doing a right tail test, it's the same value. It's just going to be positive. So I would do the same process here. Just use the alpha and degrees of freedom. And then don't forget, for a right tail test, make it positive. Now, if you have a two-tail test, actually, let me write this here. So we're using t inverse for this one. And then also t inverse here, but just make it positive. For a two-tail test, again, you could use t inverse, but the easiest way in Excel is they actually have a special inverse function for two tails, and it says 2t next to it. So you would do this. You would use your same alpha. So there's no need to like really think about how the alpha is getting split into two tails here. You can kind of skip that step. And then our degrees of freedom is 13. And I hit enter. So t dot inverse dot 2t, again, was that function here, which allows us to not have to worry about splitting the alpha ourselves. We can just use the alpha that's given in the formula. And that will give us the two-tailed version instead. And again, just don't forget you do need one positive and one negative. So here they're giving you the positive version, so make sure you also take the negative version as well here. So two-tailed, you would need one on each side. But that's kind of a nice, easy way, like I said, to go ahead and do that value. Let's see. All right, so now let's move on to how to use Excel for the p-value method. And again, we're assuming that you've done all the background stuff already here and you've done your setup. So the p-value method is actually one that you really do want to use Excel for. To try to use the table in the text is very confusing and it's not accurate because there's a lot of values that are missing. So you're estimating a lot. So I do recommend using Excel here for the p-value. So how can you find the p-value? in Excel, trying to do a hypothesis test for means and using the t-distribution instead. So again, we'll kind of start. We're going to assume a left-tailed test with the first example. We're going to let alpha equals 0.05, same sample size of n here. And I'm going to pretend that we've already done, again, the setup. So we already know our test statistic is t equals negative 2.297. So we can go ahead and assume that. So the function that you're using here instead is going to be t-dist. So I'm going to start typing in t-dist. And it's going to first ask you for your x value. By that, they actually want your test statistic value. So I would type in the negative 2.297. They do want the degrees of freedom. So here it would be 13. And then you would type in true all the time for cumulative. So you do want that true piece here. And I would go ahead and hit enter. And that would be my p-value. Okay. So again, let's do that one more time. So t.dist. My x here is going to be negative 2.297. My degrees of freedom, we said, was 13, 14 minus 1, and then you're going to go ahead and hit true. So that would be your p-value. That's it. That's your p-value right there for your left tail test. Let's say we have a right tail test. I'm going to do the same alpha. We'll do the same n. But let's say this time our test statistic was instead t equals positive 2.297. I'm going to use the same formula here. Excel does have different versions for two tails and right tails. So if you want to play around with those, you can as well. I'm trying to keep it a little bit simple so you don't have to learn too many different formulas here. So I'm going to use the same one we already did for left-tailed. So I'm going to go ahead and click that. I'm going to put in whatever my test statistic is, which is 2.297. My degrees of freedom is 13, and I'm going to use true here. And I get this value here. Now for a right tail test, just make sure you subtract this with 1, which is kind of what we've been used to doing for a lot of our right tail stuff, is subtracting things with 1. So to get the p-value, you would take 1 and subtract whatever you got here, and that would be your actual p-value. So that's one way that you could do it for a right tail test. So use the same exact formula, plug in your test statistic, but just don't forget for a right tail test, you have to subtract with 1 to get the correct p-value. All right. If you have a two-tailed test, again, let's say our n is 14, and let's say we have our test statistic here. I'm gonna, let's see, negative 1.115. If you have a two-tailed test, remember you would actually have two test statistics, one negative and one positive. I like to use the negative version here. I find it much easier because then I don't have to worry about this whole subtracting with one thing on the right side. So I would use the left side of the graph for two-tailed, use whatever your left test statistic is. And then otherwise, I'm using the same formula. So I'm going to take my t.dist. My test statistic is negative 1.115. My degrees of freedom here is still 13, and I'm typing in true. The only difference is because you have a two-tailed test, you're going to multiply this by 2. Because technically you'd have to do the area on both sides. Because the graph is symmetric, you can just double it. So what I would do is I would take this value here, and I would multiply it by 2, and that would give me my p-value. So the p-value here, this method is a bit more important. Like I said, the rejection and critical value method, for Excel, you can do it this way, but the table to use is actually very easy there. So you're welcome to use the table. But for the p-value method, the table that we have in our textbook just doesn't work very well. It has a lot of estimating. We would have to use a lot of estimating to get a p-value there. So Excel is much preferred for using the p-value method for hypothesis testing with means with sigma unknown. So the main formula you're using there is that t-dist formula. And the things you want to keep in mind is just that for a right tail test, whatever you get, you would subtract with 1. And for a two-tailed test, whatever you get, you want to multiply by 2. So those are the big takeaways that you want to keep in mind for this section.